Hi everyone. In the previous video, we discussed fishery management. So we are still discussing renewable resources, and now let's move on to forestry or timber management. So forests are also renewable resources. So most of what we discussed under fisheries also applies here. We need to recall that our objectives um, is to find the efficient level of management. And so we need to understand the role of economics in forest management to determine the efficient level of management. This objective is similar to what we focus on in fisheries. Um, Therefore, in forest economics, we focus on sustainable yield timber management. And we need to understand the level and pattern of forest use which maximizes the net present value. The word net present value is not new to you. We talked much about this and when we discussed environmental benefits and the costs, discounting the future values to obtain the present value of benefits or present value of costs. So the economic principles that determine optimal management in forests are very much similar to principles in fisheries. The major differences between forest and fisheries resources are related to biological principles. Um, Forest rotation does not get harvested every season uh, because its growth cycle is long as compared to fisheries. And we talk of forest stock. This talk, when we talk of forest stock, we are talking about the volume of the standing timber, right? Um, so from the left, if you see this left side, I mean, as time goes on, the volume of the forest or of the timber increases, right? See, this is a small tree. It's a bigger tree after some time, after some years. So as the age of trees increases, the volume of the wood goes up. But um, this growth, right? This growth, we are looking at the volume of standing timber. Over time, gives what we call a logistic curve, right? So if we look at this right side, this S shape is logistic curve, and we have edge of the tree, and we have volume of the wood. So volume is dependent on T. So V is a function of T. So a private forest owner will balance the asset value of forest against the stream of income available from use. Right. Let's discuss about the one of the review questions that usually comes. Also, you find a similar question in your homework, right? On the top corner, I just put as a reminder the formula to calculate present values. We have to discount the future values by the um, discount factor. So I is interest. Sometimes it's indicated as R. So you should not be um, confused about that. Right. So let's consider a forest with 100,000 tons of standing timber and a growth rate of 5,000 tons additional biomass per year. So this is the initial stock, right? And this is additional every year, right? So the question here is, given a price of timber, say $100 per ton, which option? So we have two options: either a clear cut, where we harvest all of the timber, or a sustainable management where we only harvest 5,000 tons of timber. We harvest the growth, the additional growth, so that we sustain the 100,000 tons. So we are only harvesting the additional, right? So which of these two options, either a clear cut where we harvest everything in the first year, or we harvest additional stock, which is sustainable management. So which one of the two is economically preferable? So option one, a clear cut. So with clear cut, we are harvesting everything, 100,000. So the revenue is 100,000 times price, right? So we can get 10 million revenue from this option, right? Option number two, we are only harvesting. We want to maintain. We sustain 100,000. We harvest the additional. So we are harvesting 5,000 tons at the same price, 100. So we are getting. So with this option, we get 500,000 every year. This is for an undefined period of time because we are sustaining this for, let's say, indefinite period. Right. So this is once off 10 million, but this is per year. So which option? Do you want 10 million now or 500,000 every year? So this would the decision, right, would be dependent on the discount rate, because these are future streams, right? We are getting this next year, every year from now until ever. So we need to calculate the present value of this benefits, stream of benefits, then compare. So if this present value is higher than 10 million, then we go for option two. If it's less, we go for option one. Right? How do we calculate present value? We need to recall the formula. Right? We cover that. So we just divide the future value by the discount rate. So suppose we are given discount rate 4%. Present value is 500,000. Okay, present value of 500,000 stream of benefits forever. We just divide the future values, the 500,000 future values, divided by 0.04, which is 4%. We get 12.5. So at 4%, sustainable management option is better. But at 6%, divide same value by 0.06, 8.33. This is less than 10 million. So a clear cut at 6%, a clear cut is better, is economically feasible. So you see, our decision is dependent on the interest rate. Right. So as the discount rate increases, the present value of the sustainable management alternative is reduced. So for us to choose the sustainable management, the odds of choosing it increases when discount rate goes down. Right. Another approach, different from this, is if you are saying if we are given 10 million, if we know this is revenue 10 million from clear cut, right? If we invest it at 6,000, just multiply this by 6%, right? If we multiply this by 10 million times 0.06, we get 600,000. It means this option, we are getting 600,000 per year, which is above the 500,000 per year for the sustainable management. So at 6,000, we choose the clear cut. The decision is similar to the first approach, right? And let's look now at the forest growth and average growth rate. Remember the S-shaped growth curve. Right, on the graph we have volume of timber on y-axis and rotation edge on the x-axis. Right. And the faint line, this one, which is more faint, which is the mean annual increment. This is the average growth rate. By average, we are saying the total biomass divided by age of forest, right? So the volume of the wood and the edge divided by the edge of the stand. This is the mean annual increment, which is this line, right? So basing on the mean annual increment, the harvest rule is to clear cut the forest when mean annual increment is maximum. Right? When is it maximum? It's maximum at this point, at when the forest is say 100 years per time. So that's the harvest rule, to clear cut the forest when mean annual increment is maximum, such that you obtain the highest volume of timber, which is the highest average annual revenue if price of timber is constant. Right. Then on the board line, right, the current annual increment. This is like the marginal product curve, which is the incremental periodic change in volume of wood by volume of wood by year. And so the maximum, the harvest rule based on the maximum, based on the mean annual increment, is the biological point of view, right? So the biological point of view says that the optimal harvest stage is when the forest reaches its maximum mean annual increment, right? And this point, the maximum, the mean annual increment, right? This maximum does not do not factor in costs, e.g., example, opportunity costs, cost of harvest, whatever. It just based on the average growth of timber, right? Which is, yes, this is biological point of view, ecological point of view. It's different with the economic point of view. So you need to know the difference between a biological harvest point and economic harvest point. So when we move on to economic optimal, right? In the previous slide, we discussed the biological point of view, which does not factor cost. But with economic optimum, we need to consider cost of harvest. For example, cost of labor, machinery, energy to cut timber, transport, etc. And also we need to discount those values. So with economic optimum, we calculate the discounted total revenue and the discounted total cost. This is similar to the previous question. So the economic objective is to maximize the economic rents. That's maximizing payments to a factor of production in excess of cost. So the optimal rotation period is when the discounted value of the difference between total revenue and total cost is maximized, right? And we discount total revenue and we discount total cost. So the maximum difference between that is the economic optimum. Recall that at higher discount rate, the shorter will be the optimal harvest period. So in a different video, I will show how we can maximize rotation period given a faster growing softwood tree or given a slower growing hardwood tree. This video will be related to your homework question, how to calculate rotation period. And on the last slide, I provide some discussion questions. Please respond to these questions for participation points. I think it's easier. Like the first one, what is renewable resource. I mean, if you at least uh, just one person, right, you get a point for that. Thank you.